In the post-collapse world, sight is no longer the primary detection system. Scent is. Long before anything sees you, it has already read you. Human scent doesn't vanish into the air the way most survivors believe. It lingers, it clings, and it travels farther than your instincts are prepared for. Under dry, open conditions, your volatile compounds can be detected from 30–50 meters. In dense, humid vegetation, the range can double to 80–120 meters because moisture traps scent closer to the ground and carries it along thermal currents. And the danger isn't theoretical. Pre-collapse canine tracking units routinely followed human scent trails 8 to 24 hours old. Some autonomous biosensors still running in low-power mode operate on the same principles. The old world was noisy. Exhaust fumes, chemicals, human crowds, asphalt heat, a shield that diluted your chemical signature. But that shield is gone. Now your scent sits exposed on bark, leaves, stones, and stagnant air pockets. A single mistake, like sweating under a heavy pack or brushing against wet foliage, can leave a detectable trace for hours. Trackers, both human and animal, don't hunt in lines. They hunt in circles, letting the air tell them where to close in. To survive, you must stop treating scent as hygiene and start treating it as threat geometry. You are broadcasting chemical information with every step. Stress levels, direction of movement, metabolic state, time since passage. And unless you learn to erase, disrupt, or redirect that signal, you will always be found first. Activated carbon is the first real barrier between your body and the world reading your chemical output, but only when it's used with precision. Most survivors wear carbon-lined clothing as if it were just another layer. That misunderstanding destroys the entire system. Activated carbon works because of its enormous internal surface area, 500 to 1500 metmern per gram. Every gram contains millions of micropores designed to trap the volatile organic compounds, VOCs, your body releases. Ammonia from sweat, fatty acids from skin oils, sulfur compounds from stress, and dozens more. When the pores are dry, open, and unsaturated, they capture your scent signature with ruthless efficiency. But when they're wet, worn down, or overloaded, they don't just fail. They leak a concentrated plume that is easier to track than your natural scent ever was. The correct method begins with understanding layering, not wearing. Your body emits 70–80% of its detectable VOCs from 5 hotspots: armpits, groin, lower back, feet, and the crease behind the knees. A proper carbon system doesn't blanket the body. It targets the hotspots with high-density panels, each no more than 2 to 4 mm thick, and secured under a breathable outer shell to prevent abrasion. This dynamic panel system allows the carbon to stay intact longer and traps scent where it forms. A full suit is optional. Targeted carbon isn't. But carbon on the body is only half the battlefield. Your gear carries more long-term scent than your skin. Shoulder straps, waist belts, pack padding, gloves, all absorb sweat and bacteria. A single uncleaned strap can broadcast your presence for hours. This is why every serious survivor builds a field carbon chamber. A sealed metal pot, dry bag, or ammo can loosely filled with granulated carbon. Place your gear inside for 45–60 minutes with a warm stone nearby, not touching. The mild heat accelerates absorption by opening micropores while pulling VOCs out of fabric. This one ritual reduces your scent footprint more than any other single action. Humidity is your enemy. At 70% pulse humidity, water vapor starts occupying the same pores that should be trapping VOCs, cutting efficiency by up to 40–50%. This is why your carbon layers must be dried over indirect heat every night. Warm, not hot, or the carbon structure collapses. Survivors who skip this step walk into the forest with carbon that behaves like ordinary cloth. And then there is abrasion. Any area where your suit rubs, elbows, shoulders, hip belts, will shed carbon dust. That dust sticks to vegetation and rock, leaving a visible trail under the right conditions. Trackers call these black flecks, breadcrumbs made by the careless. To prevent this, you reinforce high-friction zones with sacrificial fabric overlays, allowing the carbon underneath to remain untouched. Activated carbon is not magic. It is a maintenance discipline. Used correctly, it collapses your scent signature to a fraction of normal. Used carelessly, it amplifies it into a sharp, traceable spike. In a world where everything hunts by scent, precision is the only difference between disappearing and being dragged out of the dark. Enzymatic odor disruptors are not cover scents. They are chemical knives, tools designed to break down the very molecules that make you human in the olfactory spectrum. If activated carbon captures VOCs, enzymes destroy them. And in a world where every predator, every dog, and every autonomous sensor relies on those molecules to track movement, destruction is sometimes the only correct answer. To understand why enzymes matter, you must understand what your scent truly is. Human odor is built from dozens of volatile organic compounds released through sweat, breath, and bacterial metabolism. Ammonia, isovaleric acid, butyric acid, sulfides. These are the signatures that identify you long before you appear. Enzymes work by attacking the structure of these molecules. Lipase cuts apart the fatty acids that make sweat smell sour. Protease breaks down proteins that bacteria convert into pungent sulfides. Amylase dismantles complex carbohydrates that fuel odor-producing microbes. When the molecular chain is broken, the scent disappears. Not masked, neutralized. But enzymes are not permanent. In field tests before the collapse, biological odor neutralizers typically maintained high efficiency for 45–110 minutes, depending on humidity, temperature, and concentration. In cold air, their activity slows. In high heat, they degrade. This means you cannot spray once and expect invisibility. You apply with timing, intention, and coverage discipline. The correct approach begins with the 3-zone application protocol. Zone 1 covers VOC hot points, armpits, groin, chest, and the back of the neck. These areas produce the majority of your odor load. Zone 2 targets fabric contact zones, waist belts, shoulder straps, inner collars, gloves. Zone 3 is temporary and situational, hands and forearms before close contact with vegetation, tools, or surfaces that might hold scent. Enzyme without zoning is waste. Zoning without reapplication is suicide. Many survivors ruin the process through oversaturation. They coat themselves until they reek of the enzyme solution itself. This creates what trackers call a chemical halo, a cloud of artificial scent with sharp boundaries. Natural compounds disperse gradually. Artificial compounds often disperse evenly. Dogs, wolves, and even old-world biosensors detect the uniformity instantly. Predators know when something smells too clean. The solution is precision. Apply lightly, evenly, and only where the body produces odor. A fine mist is enough. Heavy spraying is a broadcast, not a disguise. But the post-collapse world rarely gifts you commercial enzyme sprays. You must know how to build your own. Fortunately, nature still produces potent enzymatic sources. Pineapple core contains bromelain, a protease powerful enough to break down proteins in minutes. Papaya latex contains papain, another enzyme capable of degrading odor-causing molecules quickly. A field-expedient mixture requires only 3 components: clean water, crushed pineapple core or papaya latex, and a pinch of salt to stabilize the enzyme. Let it sit for 30 minutes, strain it, and you have a functional compound that remains active for a short window. The solution ferments over time, so you make small batches, never more than a day's worth. But how do you know it works? You test it using a closed container VOC drop test. Rub a piece of fabric against your skin, place it in a small sealed container, and wait 5 minutes. Open it and smell. Apply your enzyme solution to another fabric piece and perform the same test. The drop-in odor intensity is your measure. If the difference is minimal, your enzyme is weak or dead. If the result is sharp and clean, your mixture is active. This crude test, simple, effective, and field-proof, is the only guarantee you have. Then comes the most overlooked reality. Enzymes don't remove scent from gear. They are designed for biological surfaces, not synthetic absorption. Using enzymes on gear simply shifts odor compounds deeper into the fabric. Carbon handles gear. Enzymes handle you. And finally, understand the tactical implications. Enzymes are not a replacement for carbon, soil, or airflow control. They are a timing tool. Use them right before contact with dense vegetation, before entering stagnant air pockets, or when you're about to cross a zone where trackers might be waiting. They give you a 110-minute window where your scent signature collapses. After that, you either refresh or switch to a different method. A survivor who relies solely on enzymes dies. A survivor who integrates enzymes into a broader scent erasure protocol becomes almost untraceable. Enzymes are sharp, temporary, and unforgiving. Use them with discipline, and you erase a layer of your existence. Use them with carelessness, and you create a chemical beacon that announces exactly who and where you are. Smoke is one of the oldest scent control tools humanity ever created. But in the post-collapse world, it is no longer superstition or ritual. It is chemistry, physics, and battlefield geometry. Used correctly, smoke does not hide your scent. It overwrites it. Used incorrectly, it amplifies your presence and creates a directional trail that even an untrained dog could follow. Most survivors treat smoke like a blanket. Professionals treat it like a controlled atmospheric weapon. To understand why smoke works, you must understand what it actually is: a dense cloud of microscopic particulates that binds to volatile organic compounds, VOCs, and disrupts the airflow patterns carrying your scent. When you step into smoke, your VOCs attach to soot, resin droplets, and ash particles. This changes both the structure and the trajectory of your scent. Trackers depend on consistent gradients, smooth scent trails that move with the wind. Smoke destroys that consistency. It replaces the gradient with noise, but noise must be engineered. Random campfire smoke is useless. What you need is a 3-phase smoke curtain, a technique borrowed from wildfire behavior studies and old-world military screening tests. The first phase is the heat layer, closest to the fire, a turbulent zone rising 1-2 meters. VOCs entering this layer break apart quickly, but the heat is unstable and unreliable. This is not where you linger. The second phase is the diffuse layer, the most important. It forms roughly 3 to 8 meters downwind of your smoke source, where the air cools and particulates spread evenly. This is the layer you use to sterilize your scent. Here, the smoke density is high enough to overwrite your signature, but not so thick that it clings to your clothing. In practical terms, you walk through this zone slowly, never stopping, allowing a uniform film to settle on your outer layer. This reduces your detectable scent footprint for the next 20-40 minutes, depending on humidity and wind. The third phase is the cold sink layer, beginning at 8 to 20 meters downwind. The heavy particulates settle, accumulating near the ground. This layer masks ground-level scent trails, confusing dogs and low-mounted sensors. It can buy you minutes, sometimes hours, when used correctly. But almost no survivor uses smoke correctly because they ignore the enemy that always defeats them: wind alignment. Trackers know that smoke manipulation fails with a mere 5-15-degree shift in wind direction. If you step into smoke while the wind is shearing sideways, your scent is not erased. It is smeared across the environment in a streak that points directly toward you. The fix is simple, but non-negotiable. Throw a handful of dry grass, watch its trajectory, then align your movement so you enter the diffuse layer head-on, not at an angle. Fuel choice is another point where amateurs betray themselves. Softwoods with high resin content, pine, fir, spruce, release aromatic compounds that create recognizable profiles. Those scents linger for hours and signal intention. Predators and humans alike know someone is trying to hide. Instead, you burn low-resin hardwoods or detritus, oak bark, elm, deadfall branches, even compressed grasses. Cedar remains an exception because its smoke contains volatile molecules that naturally interfere with VOC detection, but only in very small doses. Too much cedar creates its own signature. Survivors needing mobility rely on the microfumigation sphere, a post-collapse innovation born from necessity. Take a small steel can, punch ventilation holes near the top, fill it with dry biomass, light it, and close the lid loosely. The device emits a steady stream of cool smoke for 30-90 seconds, just enough to sterilize your clothing or break your trail before you move again. You carry it with a stick, swing it low to mask footpaths, then set it down and disappear while the plume confuses the pursuit line. This technique saved more lives in the last decade than any improvised weapon. The greatest mistake, however, is believing smoke covers your scent. It doesn't. It replaces pattern with chaos. Trackers don't lose you because they cannot smell you. They lose you because your trail stops behaving like a mammal's. A human trail is warm, directional, continuous. A smoke trail is fragmented, inconsistent, and layered with competing signals. Predators read patterns. Smoke denies them patterns, but smoke is temporary and unforgiving. It buys time, not immunity. In stagnant air, particles cling longer. In high wind, they vanish instantly. If you rely on smoke without understanding its boundaries, you will leave a broken trail that eventually reconnects to you. Master the timing. Master the wind. Master the layers. Smoke is not concealment, it is disruption. And disruption, in a world that hunts by scent, is survival. Soil and clay are not camouflage, they are chemistry. When used correctly, they bind to the volatile compounds leaving your skin and convert your scent signature into something indistinguishable from the ground itself. When used incorrectly, they amplify your odor, trap moisture, and create a bacterial bloom that makes you easier to track than before. Most survivors smear mud on their skin because they saw it in movies. Professionals study the earth they stand on. The first truth is this: not all soil is equal. The effectiveness of earth-based scent control depends on its mineral content, not its color or consistency. The three minerals that matter are kaolinite, bentonite, and elite, all of which have natural adsorption capabilities. Bentonite, for example, can absorb up to 5 to 7 times its own weight in water and pulls VOCs into its layered structure. Kaolinite adheres tightly to skin oils, reducing the release of fatty acids that form human scent. Elite acts as a microsealant, locking moisture in place and slowing bacterial activity. Any soil rich in these minerals becomes a temporary scent suppressant. Any soil lacking them becomes useless. This is why the earth in different environments behaves wildly differently. Tropical forest soil rich in organic decay is terrible for scent suppression. It holds moisture, feeds bacterial growth, and can intensify human odor within 30–90 minutes. In contrast, dry, mineral-heavy soils of temperate regions can reduce scent output for 2 to 3 hours. Clay-heavy riverbanks work well when dried into a thin paste, but fresh mud from the same bank will betray you because of bacterial load. The land communicates. Your job is to listen. Identifying usable soil is simple once you know what to look for. Take a small sample, roll it between your fingers, and note 3 signs. If it feels silky and smooth, likely kaolin-rich. If it forms a tight ribbon without crumbling, likely bentonite-heavy. If it cracks slightly but still holds shape, likely elite content. Avoid any soil that smells strongly, feels greasy, or stains your skin too darkly. These are signs of high organic content, which boosts microbial VOC production. Once you've chosen your mineral source, the next step is the 2-phase mineral bind. This is the difference between a survivor and someone playing in the mud. Phase 1 is the wet bind. Mix your mineral-rich soil with just enough water to create a thin, chalky paste. Apply it to scent hotspots, armpits, groin, back of the neck, wrists, and ankles. These are the escape valves for human odor. The wet bind absorbs the immediate VOCs and begins sealing the pores. Phase 2 is the dry seal. Dust your body lightly with dry soil or crushed clay powder. This outer layer acts as a barrier, slowing air exchange and reducing new odor emissions. Think of it as a mineral armor, soft, thin, and silent. Done correctly, this 2-phase system reduces your scent output for 90–150 minutes, depending on heat and humidity. Movement, however, destroys everything. Clay cracks when stretched, and soil dust rubs off with friction. This is why you must reapply after intense exertion or after crawling. The biggest failure survivors make is treating earth cover as binary, on or off. In reality, it is a consumable resource. You finish a mission with less clay on you than you started with. If you finish with the same amount, you didn't move enough to survive. Terrain matters too. After rain, soil particles swell with moisture. This makes them heavier, less adhesive, and less able to bind to VOCs. A fresh rainfall can cut mineral binding efficiency by 50%. In dry, windy terrain, the dust layer blows off too quickly, leaving only the wet bind, useful but incomplete. Adaptation becomes mandatory. But the deadliest mistake, the one that marks amateurs instantly, is using organic mud from swamps, riverbeds, or decaying forest floors. Organic mud contains microbial colonies that actively feed on sweat and skin oils, producing sulfur compounds far stronger than your natural scent. Trackers call it rot bloom. Dogs lock onto it instantly. Earth is not a disguise. It is a science. When chosen carefully, prepared correctly, and reapplied with discipline, soil and clay allow you to merge with the ground's chemical profile. Your scent becomes a mineral whisper instead of a mammalian broadcast. In a world where the earth itself reports your presence, you must learn to make it lie. Airflow is the invisible battlefield every survivor walks through, yet almost no one studies it. They watch the trees, not the space between them. They think scent rises or falls, but in reality it moves in cones, vortices, corridors, and thermal rivers. And unless you understand how these currents carry your chemical signature, every step you take is a message broadcast downwind. Animals, trained trackers, and autonomous sensors don't follow footprints. They follow airflow. To control scent, you must first understand the scent cone. When your body emits VOCs, they don't disperse evenly. They travel in a widening cone that extends downwind, typically at an angle of 25–40 degrees depending on temperature. In cool air, the cone tightens. In warm air, it widens. A human moving with a loose scent cone can be detected from 6,100 meters by scent-driven predators. This is not theory. This is how wolves hunted before the collapse, and how feral dogs and machine sniffers still operate. The most powerful airflow weapon you have is temperature. Warm air rises, cold air sinks. At dawn and dusk, temperature gradients flip. This creates ascending and descending scent vectors. Predictable, repeatable, exploitable. If you move uphill at night, your scent flows behind you like a low river. If you move downhill during hot midday, your scent floats upward and drifts into the canopy. Trackers know these cycles intimately. Survivors must learn them or die because of them. To manipulate airflow directly, you use both terrain and tools. Terrain is your main ally. Look for negative pressure zones, small hollows, leeward sides of boulders, the downwind edge of ridgelines. In these pockets, air swirls unpredictably, trapping and breaking scent trails. Resting in these zones reduces your detectable scent footprint by as much as 50–70% because your scent becomes a loop instead of a stream. But timing matters. These pockets shift with shifting winds. You scout them with leaves or dust, toss a handful, and watch how it falls. Straight drop means dead air. Side drift means risk. Upward curl means thermal lift, which will carry your scent far beyond where you stand. Tools, on the other hand, give you active control. Biotrackers before the collapse often trained with micro-wind generators, simple 5V motors with improvised fan blades, enough to redirect airflow in confined spaces. Post-collapse survivors adapted them to redirect scent rather than amplify it. With a palm-sized generator and a bit of power, you can create a local airflow barrier, pushing your scent into a cliff face, a stream, or a dense thicket where the cone collapses. Even a 3 to 5 km H-directed stream, barely enough to rustle a leaf, is enough to shift your scent vector off trail and into terrain where detection becomes far harder. But airflow engineering is not just about shifting the scent cone. It's about erasing the trail you leave behind. When you stop moving, your scent pools. When you walk again, that pool becomes a breadcrumb. To break the breadcrumb chain, you use vent tunnels, depressions, ditches, cracks in terrain that pull air downward. When you cross these with careful timing, your scent falls into them, sinks, and disperses instead of stretching forward. Even a shallow drainage ditch, less than half a meter deep, can erase 20 to 40 meters of your projected scent trail if you move through it during a downward thermal phase. Yet the most fatal mistake survivors make is hiding in wind shadows. A wind shadow forms on the downwind side of obstacles, boulders, abandoned vehicles, ruined walls. Survivors think these places conceal them. Instead, they create a scent bubble, a stagnant pocket where your VOCs accumulate in high density. When wind shifts, even slightly, that bubble bursts and travels as a single heavy plume. Trackers love wind shadows because they tell a story. How long you stayed, how stressed you were, even the direction you left in. You must never remain in one for more than a few seconds. Finally, you must master the simplest airflow diagnostic tool, the leaf microflutter test. Hold a thin leaf or blade of grass at arm's length. Watch for microvibrations. If it flutters subtly, the air is moving at 1–2 km/h, enough to carry scent. If it trembles visibly, the air is in the 3 to 5 km/h range, the danger zone where scent cones stabilize and travel farther. If it stays still, the air is stagnant, Ideal for enzyme use but dangerous for resting. Airflow manipulation turns scent control from reaction into prediction. You stop being a creature that leaves a trail and become a creature whose trail is shaped, broken, and weaponized. When you understand how scent travels, you stop being hunted by the air and start using the air to erase your existence. Biological interrupters are the most misunderstood scent control tool in the post-collapse world. Amateurs treat them like folklore. Rub animal droppings on yourself, scatter predator scent, carry herbs to hide your smell. That nonsense gets people killed because biological scents don't mask human odor. They rewrite instinctive interpretation patterns in the creatures and sensors, trying to track you. To use them correctly, you must understand not what they smell like, but what they signal. Every animal interprets scent through three instinct categories: deterrent, attractant, and neutral disruptor. A deterrent tells predators or scavengers that a more dominant creature has already claimed the area. An attractant signals prey or food source. A neutral disruptor confuses pattern recognition. It doesn't push pursuit away or draw it closer. It bends the logic of the trail. The most effective deterrents come from scavenger carnivores, not apex predators. Many survivors smear wolf or cougar scat, believing it will scare off pursuit. It doesn't. Apex predators produce sharp, distinctive signatures recognized by both animals and trained dogs. These signatures don't hide your trail, they frame it. Trackers instantly know a human tried to disguise themselves. Worse, apex scat draws curious predators rather than repelling them. What actually works as deterrent is scent from opportunistic carrion feeders, species whose odor signals territory fatigue and low food value. In the pre-collapse world, field tests showed that dogs hesitated or veered away from trails contaminated with raccoon, hyena-like scavenger analogs, or high-rot microbial colonies by 15–30%. These aren't dramatic numbers, but even a modest hesitation buys time. Attractants sound useless for survival until you realize they can be weaponized to create false scent corridors. Trails rich in decaying plant oils or prey animal musk pull animal trackers and scavenger units off your original path. When deployed in the right terrain, a false corridor can divert pursuit 5,200 meters offline. The key is spacing. You don't leave a line of attractant, you leave clusters. Scattered clusters mimic natural scent pockets that drift irregularly through the landscape. A straight attractant line spells human strategy. Clusters spell chaos. Neutral disruptors are the most subtle and the most powerful. These include plants high in isoprene, terpenes, and microbial compounds that destabilize VOC perception. Old-world scent lab tests showed that isoprene-rich leaves, eucalyptus relatives, some wild basil species, certain shrubs, could reduce dog accuracy by 20–40% for short intervals. They work not because they smell strong, but because they overload olfactory receptors and distort pattern gradients. You don't rub them all over your body, you layer them lightly onto your clothing in thin rotational cycles. This leads to the doctrine known as biome layering. Instead of relying on one biological scent, you rotate through several categories across 24–72 hours to prevent pattern recognition by AI sensors, trained dogs, or experienced trackers. A basic cycle looks like this. Day 1. Isoprene-rich plant disruptor. Day 2. Mineral-heavy soil or enzyme-based reduction. Day 3. A mild deterrent pocket placed behind you during movement, never on your body. This rotation breaks repetition. Repetition is death. Hunters, organic or mechanical, track patterns, not moments. But there is one fatal mistake nearly all novices make: applying biological scents directly to their skin. Skin heat activates compounds, intensifying them and creating abnormal chemical ratios. Predators recognize this instantly. Even dogs hesitate because the scent profile becomes unnatural. Biological interrupters must never sit on skin. They go on outer layers, on gear edges, or on the environment behind you. You are not trying to become an animal. You are trying to mislead an animal. Used correctly, biological interrupters bend instinct, fracture pursuit logic, and sabotage signal interpretation. Used carelessly, they mark you as prey, bait, or intruder, each one equally lethal. When you control biological signals, you aren't just erasing your scent, you are corrupting the very instincts that operate the hunt. Scent erasure is not a trick. It is not a product. It is not something you do once before a mission. In the post-collapse world, scent control is a discipline, a continuous operational routine that shapes how you move, how you rest, how you carry gear, and how long you stay alive. Every tool you've learned, carbon, enzymes, smoke, minerals, airflow, biological interrupters, functions only as part of a larger doctrine. Alone, each tool buys minutes. Together, they build a system that collapses your scent signature across an entire day. The first operational rule is precision, not saturation. Survivors who overuse any one method, too much enzyme, too much smoke, too much biological scent, become easier to track, not harder. Predators read intensity as intent. Trackers read uniformity as manipulation. Precision means small applications, targeted zones, and deliberate timing. The second rule is layer, don't mix. Carbon adsorbs. Enzymes break down. Clay seals. Smoke disrupts. Airflow redirects. Biological scents confuse. When you mix them indiscriminately, you cancel out the mechanisms that make each tool effective. When you layer them in the correct sequence, carbon for baseline suppression, enzyme before movement, airflow management during travel, mineral binding as reinforcement, smoke when breaking contact, biological signals when redirecting pursuit, you create a multi-tiered barrier that no single detection method can reliably interpret. The third rule is test, don't guess. In the old world, technology compensated for mistakes. In this one, your nose is the lab. The closed container VOC test, the leaf micro flutter check, the abrasion check on carbon panels, the soil ribbon test, all of them reveal what theory cannot. Survivors who test their tools outperform those who assume their tools are functioning. Guessing gets you followed. Testing lets you disappear. The fourth rule is routine over one-offs. Scent discipline is a cycle. Dry carbon nightly, rebind clay after exertion, refresh enzyme during dense vegetation travel. Manage airflow every time the terrain shifts. Reset biological patterns every 24-72 hours. The survivors who treat scent erasure as a ritual survive encounters they never even notice. The ones who treat it as emergency preparation die in routine movement. And here is the closure you must accept. You will never be scent invisible. That is a fantasy. Every creature with a nose or a sensor with a chemical reader will always detect something. Your task is not to become invisible. Your task is to become unreadable, an anomaly in the landscape, a broken gradient in the airflow, a signal that contradicts itself until the hunter abandons the pursuit because the pattern no longer makes sense. Disappear from interpretation, and the world that hunts by scent loses its advantage. In a landscape where everything smells, the only survivor is the one who learns to smell like nothing that matters.